Hello students, so welcome to my next online class. So in this video I am going to start a new chapter, that is physical quantities and measurement. Okay, so first of all we will see what do you mean by the physical quantity. So quantities that can be measured are called physical quantities. That means any quantity which you can measure. Like if I say calculate the speed of any body, that means calculate the speed of any car. That means we know speed equals to distance by time. So by calculating its distance, how much distance it has covered, how much time it has taken, so we can calculate this speed. So likewise speed, we have mass, we have time, we have length, okay, we have temperature. So numerous number of quantities are there. So the object which we can measure, that means the quantities that we can measure, that comes under physical quantities. That means here measurement plays a vital role in each and every aspect. So without measurement we cannot estimate, we cannot make a building in fact. So for making a building we should know how much materials is required. Until and unless we know how much materials is required, we cannot estimate its cost. So in every cases, in every day-to-day life, measurement plays a vital role. Okay, so in this chapter we will see there are two quantities, that is fundamental quantities and derived quantities. So physical quantities can be classified into fundamental and derived. Fundamental quantities are those quantities which don't depend on other quantities. Okay, and derived quantities are those quantities which depend upon fundamental quantities. So we'll understand this definition with the help of example. Like you see in the SI unit we have 7 fundamental quantities like length. Whenever you are measuring any length, we need to measure in terms of meter or centimeter, right? So SI unit, when I am saying, so what is the SI unit of length? That is meter. SI unit of mass, that is kg. SI unit of time is second. Temperature, Kelvin. Electric current, ampere. Luminous intensity, candela. Amount of substance, how much substance it is contained here, generally we used in chemistry this one. So amount of salt, amount of chemicals taken, that is calculated in terms of mole. So these are the fundamental quantities. That means length does not depend on other quantity, mass also does not depend, time similarly for other cases, temperature, electric current, luminous intensity and amount of substance. Okay, so these all are fundamental quantities. So what are fundamental quantities? I repeat, fundamental quantities are those quantities which don't depend on other quantities, or you can say fundamental quantities are those quantities which are independent. Okay, independent means it does not depend. Now let's see what are the derived quantities. So derived quantities are those quantities which depend upon fundamental quantities. Like if any physical quantity like area, suppose we need to find area, and if the area of a land is in terms of length and breadth, so if we need to calculate the area of a rectangle, then what is the formula? Length into breadth. So length, when you are measuring any length, that has to be in meter. Breadth also, when you are measuring it, has to be in meter. That means meter into meter, that is meter square. So we can say area is depending upon length. Okay, area is depending upon length. So what is the unit of length? Meter. So similarly, unit of length is also meter, unit of breadth is also meter. Okay, so meter into meter, meter square. So area is a derived quantity. Area, that means it is based upon fundamental quantity. So therefore we define derived quantities. Derived quantities are those quantities, these all quantities, they depend upon fundamental quantities. So without fundamental quantities, so we cannot write the formula for these quantities. Okay, let's see for volume. Volume equals to, now if it is a cuboid, volume is length into breadth into height. Again, length, breadth and height, all these three are measured in terms of meter. So we'll get a meter cube here. Similarly, speed equals to distance by time. Distance, we calculate what distance is in meter, that is meter by second, that is meter per second. Acceleration, velocity by time, velocity is meter per second. When I say acceleration is v by t, that is velocity by time. Velocity and speed more or less they are same, only it differs in terms of direction. Okay, so velocity is here meter per second and time is in second, that means 2 seconds are there, that's a second square. So therefore I wrote meter per second square. Density is mass by volume. Mass depends upon kg, and volume again length into breadth into height, therefore meter cube, so kg per meter cube. So these all derived units, they depend upon fundamental units. Okay, so this one you need to write in your exercise book. So on the board you can see volume. Now when we are asked to calculate the volume, so we need to calculate its length, its breadth and its height. So all length, breadth and height are in meter. So what will be the unit of a volume? It will be meter cube, always cubic meter or meter cube. Now if any object is very small, like if I say brick is very small, that means dimensions are very small, that means length, breadth and height are very small. So in that case we calculate in terms of centimeter. So that time we will find centimeter cube. Okay, if the objects are big, we need to calculate this volume, then it will be in meter cube, and smaller objects will be in centimeter cube. Okay, so amount of space occupied by an object is called volume. That means the gases and liquids, they also have volume. Now you can say, suppose there is one bicycle tire, okay, and there is a bigger truck tire. So bicycle tire, the gases or the air inside the bicycle tire will have less volume as compared to the air in the truck tire. Okay, so volume of air in bicycle is less than the volume of air in truck tire. So in that case, it's like liquid also has volume. You see, volume of water in a bucket, suppose there is a bucket, a bigger bucket, and it is containing water. Okay, let us consider the capacity of that bucket may consider as 3 liter. Okay, so the volume of water, whatever water will be stored in that bucket, that volume of water definitely it will be more than the volume of water in a bottle. That means the bottle, in that here the liquid occupied is less space, so its volume is less. But in case of a bucket, the water is occupying more space, so volume will be more. Okay, so in case of liquid we measure in terms of milliliter, and in terms of solid we measure in terms of meter cube or centimeter cube. Like 1 meter cube means 1 meter into 1 meter into 1 meter. 1 meter means 100 centimeter. Similarly, in place of meter I wrote 100 centimeter. So if you count the number of zeros, you will get 6 zeros, that is 10 to the power 6 centimeter cube. Okay, so 1 meter cube equals to how much centimeter cube? 1 meter cube equals to 10 to the power 6 centimeter cube. So this is the relation between meter cube and centimeter cube. Now milliliter and centimeter, what is the relation between milliliter and centimeter? Here you see 1 milliliter equals to 1 centimeter cube, and 1 liter equals to 1000 milliliter. Okay, so when I say I have 1 liter of water, that means how much milliliter water do I have? I have 1000 milliliter, and 1 milliliter means 1 centimeter cube. So if you substitute in place of milliliter centimeter cube, then 1 liter will be 1000 centimeter cube. And we know 1 meter equals to 100 centimeter, and 1 centimeter equals to 1 by 100 meter. So 1 centimeter cube when I write, that means 1 by 100 into 1 by 100 into 1 by 100 meter cube. Okay, that means I am representing centimeter cube in terms of meter cube. Just now we have seen 1 meter cube equals to 10 to the power 6 centimeter cube. So how much centimeter cube is 1 meter cube? That is 1 centimeter cube is 1 by 100 meter, 1 by 100 meter, 1 by 100 meter. So 6 zeros are there. These 6 zeros, when it will come in the numerator, that is minus 6. That means the exponent will become minus. The power will become minus here. That means 1 centimeter cube equals to 10 to the power minus 6 meter cube. So these conversions are very important. Okay, so in a numericals and all, or any measurement, when we do such measurement like converting meter into centimeter or milliliter to liter, so these conversions are important. So if you see in your textbook, we have measuring the volume of solid, like it based upon shape. If the shape is in form of cube, then length into length into length, that means length cube, okay, or meter cube. So volume of a cube is m to the power 3, that is meter cube. Now if it is in form of cuboid form, that means it has length, it has height and it has breadth. So that time we will have length into breadth into height, the volume remains same. So volume unit of this shape cube is also meter cube, this is also meter cube. So for measuring the volume of any liquid, we use a measuring jar. Okay, you might have seen the milkman or the person those who are selling oils. Okay, so they use this type of jars, that is measuring jar. Okay, one more we have, that is measuring cylinder. This one we use in a laboratory, okay, to measure the volume of a liquid. So it has a marking here that is called graduated. You see the markings are there, and when the chemicals are being poured in this measuring cylinder, so we can actually calculate how much quantity of chemicals we are using in the laboratory. So first we will measure by using this measuring cylinder, then only we use in an experiment. Now the question comes, when you are pouring any chemical in any test tube or any cylinder, we'll get two types of reading like this. Some substance, it sticks with the wall of the container, like water. If you pour water in a glass, you'll find that shape is like this. The top part is curved like this. This is called concave meniscus, and the dash line which you see, this dash line, dot line, that is called meniscus. Okay, so meniscus means it is the curve, it is the line which passes through the curve of the liquid. So meniscus can be two types. One is concave meniscus, one can be convex meniscus. So concave meniscus we get when any substance touches with the container. Okay, so that means if there is adhesive force. Now this is a new term for you, that is force of adhesion. Adhesion means the water particles or water molecules, they stick with the container. So as it sticks, so we get a concave shape. But in mercury, as the density is more, say they don't stick with the container, so we get here as a convex meniscus. Now there is a two term, volume and capacity. Just now we have seen volume means is the amount of space occupied by an object. If an object is occupying more space, then we say that its volume is more. If an object occupies less space, then we say that its volume is less. Now how it is different from capacity, we'll see now. Let us consider two bottles. The capacity of this bottle is said to be as 750 milliliter. That means this bottle can hold 750 milliliter of liquid only. But when I say what is the volume of liquid inside this bottle, so that is 300 milliliter. Okay, so inside the bottle there is 300 milliliter of liquid, but the capacity of this bottle may be big. Okay, so what is capacity here? You see in the definition, liquids are stored in containers. The maximum volume of a liquid that can be stored in a container is called its capacity. That is, maximum liquid that can be stored in this bottle is the capacity of this bottle. But how much liquid is stored there, that is the volume of the liquid. Okay, the quantity of matter is stored in that container. So you might ask, what is the difference between volume and capacity? So you need to write the definition of volume, then capacity, and you have to explain in terms of bottles, okay, in terms of examples like this. So this will be your homework. So you need to write the correct answer like this. Choose the correct option to fill in the blanks. There are 4 questions. I am leaving up to you. So this one you will solve. Similarly, next physical quantity we have area. The amount of surface covered by a closed shape is called its area. So two things are there. One is occupied and one is covered. That means the amount of space covered by a closed shape is called its area, but the amount of substance occupied by an object is called its volume. Okay, so generally volume we calculate how much liquid has been occupied that container there, or how much space that is occupied by that object. But here we have area. So area unit is meter square. That means if I say what is the area of a square, that means length into length, that is meter into meter, meter square. So area is also a derived quantity. Okay, so smaller quantities can be in centimeter cube, it can be in meter, kilometer square. So this all are conversion. Now similarly 1 kilometer square means 1 kilometer into 1 kilometer. 1 kilometer equals to 1000 meter. So 1000 and 1000, that means 6 zeros are there. So 6 zeros meter square. Similarly, when 1 hectare means 1 hectometer into 1 hectometer. That means this will be 1 hecto square. Okay, square is missing here. So 1 hectometer equals to 100 meter. So 1 square hectometer equals to how much meter square? That means 4 zeros are there. Okay, that is 10,000 meter square. Generally here it has to be 1000 meter, or let it be 100 meter only here. That means 100 meter into 100 meter, 4 zeros are there, that is 40, that means 10,000 meter square. So area of regular shapes can be calculated easily, like regular shapes like square, rectangles and triangles, circles, that can be calculated easily. Like if I say what is the area of square, that means length into length, like rectangle length into breadth, and triangles, if we want to calculate the area of triangle, that means half base into height. So there are formulas. So here we have shape, square and rectangle, so length into length and length into breadth. So this area is also is a derived unit. Okay, so SI unit will be meter square or centimeter square. So SI unit, when I say, that means we have to write meter square. When I say CGS unit, that time we have to write centimeter square. And this will also be homework, so you have to go through this activity. Okay, and you have to see how to calculate the area of any irregular object. Generally we can calculate the area of square, rectangle, triangle, circle, but if I need to calculate the area of any irregular square, so how will calculating? Means you have to go through this activity by yourself. Okay, and you see here one example is also given here, so based upon this you will do it. And here there is a comparison between area and volume. So in this class only this much. So you will write in your exercise book the important terms, important topics, along with the conversions and all. So in between I may ask your copy in my WhatsApp group. Okay, so your copy should be up to date. Thank you.